Video 2.8 is about empirical and molecular formulas and how to tell the difference between the two. By the end of this video, you should be able to identify which is an imperial and which is a molecular formulas, calculate empirical formulas, and calculate molecular formulas. Basically, empirical formula is just a different way to write out a chemical formula. And what has happened is that it is written in its reduced form. So just like you can reduce fractions, like I can take 2 over 4 and reduce it to 1/2, you can reduce a molecular formula, which molecular just means it has all the molecules written out. So you can reduce a formula that has all the molecules written out into an empirical formula just by reducing, basically, it's not a fraction, but these little coefficient numbers. So like number 1, C2H2. It is not empirical. Both of these are 2's. So I can reduce it just to CH, 1C and 1H. So basically I've divided both these numbers by 2, and that's the empirical formula. Number 2 also is not empirical. You can see my subscripts are a 6, a 12, and a 6. All of those are divisible by 2, so I can reduce it. Actually, they're all divisible by 6, even better. So divided by 6, I get 1, 2, 1. So that's the empirical formula for glucose, which is what that is. Number 3, you can see this is a 1 and a 2. It cannot be reduced any further, so that one actually is an empirical formula as written. Then this last one, I have a 2 and a 2. Both of those obviously divisible by 2, so I can reduce number 4 to just NaOH by getting rid of those 2's and making them 1's. 1 Na, 1 O, and 1 H. So that's how you create an empirical formula. Remember, it's just the reduced version of the molecular formula, which has all the molecules written out, and sometimes they're the same if no reduction can be done. So going the other direction, molecular formula are some multiple of the empirical formula, whether it's a 2, 4, 3, 4. So you see this empirical formula CH4. The molecular formula could be any one of these. If I multiply it by 1, it stays CH4. If I multiply it by 2, C2H8, because 8 times 2 is 4. I can multiply it by 3 and get C3H12, and I can just go on and on and on to infinity, really, with that, just by multiplying it by a different number and expanding that formula. So here's a way to calculate one from the other. I have this problem that says a compound whose empirical formula is NH3 has a mass of 34 grams per mole. What is the molecular formula? So basically, we need to figure out what the multiple is. Is it multiplied by 1, 2, 3, 4? What's the multiple in order to figure out the molecular formula? And we can do that using the mass because we have the periodic table. So what we do is we take our NH3, which is what we're given, figure out its mass. You look on the periodic table, add up all the masses, you get 17 grams per mole. And then we divide 34 divided by 17. Let's take the bigger number on top with these problems. But 34 divided by 17 is 2. That means my multiplier is 2. So my actual formula, my molecular formula, is N2H6. Because I've multiplied 1 times 2 is 2, and 3 times 2 is 6. So in order to convert that empirical formula to molecular, you figure out the molar mass of the formula, take the mass that you're given divided by the molar mass, and you get your multiplier. And that will give you your molecular formula. Now, we can kind of go backwards. It says find the mass of the empirical formula. Oh, I see what I'm doing here. I lost my place. These are the steps to the problem we just did. You might want to jot them down. So first you find the mass of the empirical formula. We did that with the periodic table. Then you divide the mass that you're given by the empirical mass, which came from the periodic table. This was in the problem, periodic table. And then distribute your answer from the division problem throughout the empirical formula. So here's another example of that. You can see with the steps. So a compound has a mass of 45 grams per mole. The empirical formula is CH3. What is the molecular formula? So step number 1, find the mass of this formula, the empirical formula. Look on the periodic table. C is 12, H is each one, so we should get around 15. CH3, 15 grams per mole. Next step, divide the mass that you're given, right here, by the empirical mass, which we calculated. 45 divided by 15 is 3. Then the last step is to distribute that through. 3 times 1 is 3, 3 times 3 is 9, and that gives us our molecular formula, C3H9. Now we can also calculate the empirical formula from percent. Remember we learned a few videos ago about how to calculate the percent. So let's see how that's done. Here's the problem. It says find the empirical formula of a compound that is 40.92% carbon, 4.58% hydrogen, and 54.5% oxygen by mass. So that's how much oxygen, hydrogen, and carbon is in our compound. So here are the steps to doing this. 1, we convert the percent to grams. So we just take it and change it. Get rid of the percent, make it grams. So I have 40.92 grams of carbon from the percent, 4.58 grams of hydrogen, and 54.5 grams of oxygen. That just makes it easier to work with when we do our problem. So just remove out the percent, change it to grams. That's step 1, super easy. Step 2, we're going to convert the mass to moles. That comes from the periodic table. 40.92 divided by 12 means I have 3.4 moles of carbon. 4.58 divided by 1 is 4.58 moles of hydrogen. And 54.5 divided by 16, 3.40 moles of oxygen. These 3 divided by numbers came from the periodic table. This is how we convert mass to moles. You've done a million of these by now. So that should be old hat. The next step is you divide each element's moles by the smallest number of moles. So you look here, which one of these is smallest? Well, carbon and oxygen tie. It doesn't really matter. You just divide by the smallest number. So 3.4 divided by 3.4 gives us 1. 4.8 divided by 3.4 is 1.5. And 3.4 divided by 3.4 is 1. So here's my ratio of one to the other. And then lastly, I need to turn that into whole numbers. We can't have 1.5. I can't get 1.5 hydrogen atoms. They don't break in half. So if I multiply those by 2, I get 2 carbons, 3 hydrogens, 2 oxygens. So we found that whole number ratio. Just by multiplying everything by 2, I have no decimals left at all.